Hello, my name is Palav.
My name is Ziyang.
We are part of Team 40 and will be giving the technical presentation. In the recent years, there are more than 1,000 people who have been diagnosed with ALS. Improving these people's life qualities has now become a major topic. In order to contribute to improving the lives of ALS patients, we plan to create a voice banking application to help them communicate with their loved ones using their voice, preserving their identity. The key requirements for our application are: it needs to create a custom voice print file, it also needs to provide a platform for text-to-speech, and accurately bank a user's voice. So let's look at the application structure first. The user logs onto the computer and runs the app. The app is a compiled MFC application, so they can run a .exe directly from the computer. When the app begins, it initializes the Docker container in the background that does all the Anima magic for TTS. After the Docker's containers are initialized, the MFC application is ready to use. The MFC first allows you to record your voice. When you record your voice, you read out an extract that the MFC provides, and it is saved as a .wav file. This audio recording is saved into the temp folder. And then the MFC sends a command to the local host, performing a HTTP GET command on a Flask endpoint /record. As the MFC has stored the user's voice recording now, it goes to the local host /record endpoint, which triggers the Python code that reads from the sound file stored in the temp folder and creates an Anima voice print file. We have created a brand new file extension called .anima profile. This holds all the required information for a user's voice model. Now the user has successfully created their Anima file, which can be used in the future for TTS. Let's see how this can be done. When the user wants to read some text out in their voice, they just type the text into the MFC application and click speak. When they do this, the information that they have just inputted is written into the data.json. Just like last time, the MFC will reach out to the localhost /play endpoint, which is assigned to perform the TTS function in the Python. This takes the information from the data.json, such as what profile they want to use and what text they want to synthesize, and it creates the output synthesized voice. This is then outputted to the user as sound. So the user has now successfully synthesized their voice using their Anima profile. The backend program is based on the Coqui TTS library. This library provides accurate voice synthesis and provides pre-trained base models that we can use with support for many languages. The first thing that I did on the backend is write the functions needed to meet the requirements using the CLI. I created two CLI commands. One to create an Anima voice print file using user inputted audio, and the other allows you to use that voice print file to synthesize voice using user inputted text. After I had gotten this working, I tried to compile the program using Nuitka. Nuitka is a Python compiler that can convert Python code into native C, making it highly efficient and providing a standalone executable file. While trying to compile using Nuitka, I faced many compilation errors and obstacles. With little help available anywhere, I worked through the errors, but there was just not enough time or resources available to be able to complete this compilation process. I also attempted to use other compilers such as PyInstaller, but had no luck as they all had their own error chains. Most of these errors came from within dependencies of the Coqui TTS library. I believe that a compilation can be done in the future, but due to lack of time, we had to find an alternative. This was very important as the program needed to be distributable, and the MFC front end needed to communicate successfully with the Python application too. To get around this issue, we used Docker. Docker is a tool that is used for development and deployment. It packages applications into standardized units for distribution. To pass user inputted configuration and text from the MFC front end to the Python backend, all information was constantly written to a JSON file. This was fairly easy as functionality for reading and writing to JSON files is built into Python. This future-proofs the communication between the MFC and the Python, as it is also the intended mode of communication once Python is compiled properly. As Docker containers are self-contained, we need to find a way to access them from the outside. So, I use Flask to set up two basic endpoints, localhost/record and localhost/play. These simply run the respected Python code when they receive a HTTP signal from another application on the computer. In our case, the MFC can do a HTTP GET operation on any of the endpoints to run code from within Docker indirectly. When we go to the localhost/record endpoint, the program runs an operation that imports the input audio recording of the user and passes that through the COQUI engine. When the user wants to perform TTS, the Flask endpoint localhost/play is used, causing a Python function to run that reads the variables from the data.json. This JSON contains the path of the .anima profile to use, and then also what the text the user wants to say as well. After that, the Python loads the data from the .anima profile voice print file and runs the COQUI TTS algorithm. This produces an output waveform, which is stored as audio output into a folder for the front end to output as sound, or it can optionally also be indirectly outputted using any available audio devices.
For the front end, at the user interaction part, we use huge button in our program as patients have difficulty moving. The large site can help them press button easily, especially when they use some special input devices such as eye trackers. Then user cannot click any buttons when the program is loading to make it robust. At function realize part, to initialize and start Docker when the application is opened, we use batch files. Then, to constantly communicate and run code inside Docker, we use AFX next package to send HTTP requests to Docker. For the speech function, we use JSON file to store the input text. Then the backend reads the JSON file to generate a sound file. Then the front end can play the sound file for the user to hear. For record part, we use the volume open, volume stop, volume reset to record voice data. And then use the voicing add buffer and write function in save file class to generate the audio file. For the OCR part, we use TextRect to recognize text in a photo. Then for getting the highlight text, I use the getSelect function to get the start and end point of the highlight text. And then use write function and translate function to extract the text that we needed.
There are two main accomplishments in this project. We have successfully been able to convert text to speech in the user's voice and read out highlighted text content from a picture.
Here are our main achievements for this project. Thank you for listening.